Hello everyone, my name is Lakshmi Tilsam from Department of CSEM. Today I am going to present on the topic Introduction to Finite Automata under the subject of Theory of Computation. Today we are going to learn about what is finite automata. What is finite automata? Finite automata is a finite automata is a one of the fundamental is a one of the fundamental models in the theory of computation. It is basically a mathematical model that represent a system which can be in a one state at a time and can move between state based on the inputs. In simple words, we can say that finite automata is like a machine that reads the input symbol by the symbols and change its states and finally tells whether the input is accepted or rejected. Why we call it as a finite? Why we not called as a infinite automata? Because it is called as a finite automata because it has a fixed number of fine states. For example, if a machine have two states or a five state or 10 state, but always a limited number of states, it does not have a non-limit means infinite number of states. So it can store unlimited data like a computer. Its memory is limited to states it can move between. That's why it is used for simple decision making system such as pattern checking, Linux analysis, and string validations. Then, in how to define a finite automata. Here is a simple definition of finite automata. Finite automata is usually defined as five tuples. Five tuples are Q, summation, delta, Q naught, F. What are they? Q means what? Q is a set of states. Means set of states means Q naught. Set of states what are we used for the defining or designing a finite automata. These are used finite automata. Q means set of states. Q naught, Q1, Q2. These are states we use to define a finite atom or design a finite atom. Summation means input symbols. Here, here 0 and 1 are the here in this example, 0, 1, 1 are the input symbols. So we defined this in summation. Then delta. Delta means transition function, which we use to define the one state to next state. Then next Q naught is the start state of the machine, where we define the where the machine is starts. Then F means a set of accepting states. F means there are number of final states. So Q naught means only one state, initial state or one start state. F means they have multiple final state or one final state, or it also called as a accepting state. For example, we defining a finite automata. Design a finite automata that accepts all strings over 0 and 1 that ends with 1. Here we need to define a finite automata in such a way that it ends with 1 and it take any number of zeros and but it ends with 1. Here we need to check whether the last symbol in input is 1 or either 0. So we took two instances states like Q0 and Q1. We use two states, Q0 and Q1, and we move one state to another state basis on input. Here we defining Q0 to a self-loop 0. Means it can take any number of zeros, and after taking any number of zero, it in the state Q0. When it accept 1, it go to Q1 state and it is a final state. We can make double circles that defines the Q1, that is final state. If input symbol is 1, X, it is accepted because ends with 1 we need. And if 0, 1, S, it is accepted because it is ends with 1. So 1, 0, 1, it is also accepted because it ends with 1. So if it have 1, 0, 0 means no, it is rejected because we want to design a finite atom in such a way that it ends with 1. So it not takes 1, 0, 0. So it, and if it is only 0, it is also rejected. That is all about the finite automata and how to define a finite automata and what is a finite automata. Thank you for listening.